We are counting down the 10 most engine-destroying oil additives and revealing 5 that actually work. From common do-it-yourself fixes that quietly sabotage seals and oil flow, to banned chemicals that corrode bearings and trap owners with disastrous repairs, each entry was ranked for proven risk and real-world damage. But which additive ranked as the biggest threat, and which products truly deliver safe performance? Let us begin the countdown with number 10. High-mileage oil additives often promise to stop leaks in older engines, but their secret is aggressive chemistry. Many of these products use strong ester or solvent-based agents meant to swell rubber seals. In small amounts, this can help with minor leaks, but when over-concentrated, these chemicals push seals far beyond their design. The rubber becomes soft and jelly-like, losing its ability to spring back. Overdosing leads seals to overexpand, then split or tear, causing even worse leaks than before. Factory oils use much lower concentrations for a reason. Overdosing with these additives trades a slow drip for a much bigger repair bill down the road. Thick, honey-like stop-leak additives promise to fix leaks by boosting oil pressure, but their real effect is far more dangerous. These products use heavy polymers that do not fully dissolve, settling in the oil pan and forming sticky layers. On a cold morning, that thick fraction can restrict oil flow through the pickup screen, starving the engine of lubrication just when it is needed most. Mechanics have found lifters and fine oil galleries clogged with residue from these additives, leading to sudden drops in oil pressure and noisy valve trains. The short-term gain of a quieter leak often turns into a much bigger problem lurking in the sump, waiting for the next cold start to strike. Viscosity index improvers are the polymers that help modern engine oil stay the right thickness across temperature swings. But when cheap additives dump in too much of this thickener, the oil's chemistry is thrown off balance. Instead of flowing smoothly, overdosed oil can shear down under the stress of high-revving or turbocharged engines. The long polymer chains break apart, turning what should be a stable liquid into a gelatinous sludge. Lab tests show this sludge can plug oil pickup screens and force pumps to work harder, raising the risk of oil starvation. Some engines come apart to reveal pickup tubes packed with stringy, broken polymer gel, evidence of an oil system strangled by an overdose of viscosity improver. Instead of protecting the engine, these thickeners end up choking it, especially when used outside the careful balance set by oil manufacturers. Solvent-based performance additives promise instant horsepower and a free revving feel, but the chemistry behind these claims is anything but protective. Most of these bottles are packed with light solvents, such as naphtha, kerosene, or mineral spirits. Those solvents thin out the oil far below factory specifications. Independent lab tests show a dramatic drop in viscosity at operating temperature, sometimes cutting it by half. The oil's total base number, TBN, also plummets, slashing its ability to neutralize acids. This leaves bearings and cam surfaces exposed, with a thinner film standing between metal parts. Used oil analysis after just a few hundred miles often reveals a spike in wear metals like iron and copper. While the engine might sound livelier at first, the real cost is paid in accelerated wear and loss protection. These so-called power boosters trade long-term engine health for a fleeting sense of performance, leaving owners with a much bigger problem down the road. 10-minute engine flushes loaded with kerosene or naphtha promise a quick fix for sludge, but the reality is far more dangerous. These solvent-heavy products crash the oil's viscosity almost immediately, stripping away the protective boundary films that shield bearings and cam surfaces from metal-to-metal contact. As the flush circulates, loosened sludge breaks free in large chunks, threatening to clog the oil pickup screen and starve the engine of lubrication. Even a single use can leave critical areas exposed, leading to rapid bearing wear during the flush cycle itself. Automakers have issued technical bulletins warning against these uncontrolled flushes, forbidding their use outside of tightly managed service procedures. The risk is simple. A shortcut cleanout can turn into a catastrophic failure, with damage that shows up long after the engine has been buttoned up. The next threat goes even deeper as the chemistry shifts from dilution to outright corrosion. Chlorinated paraffins once found favor as extreme pressure boosters in aftermarket oil additives, but their chemistry brings a hidden threat. When exposed to the heat of a running engine, these compounds break down and form hydrochloric acid, a corrosive agent that attacks vital metal components. Tribology labs have documented acid pitting on main bearings and etched scars across cam lobes in engines dosed with chlorinated extreme pressure additives. The damage is not just cosmetic. Corrosive wear accelerates bearing failure, turning smooth journals rough and leaving engines vulnerable to catastrophic breakdowns. Oil removed from these engines often comes out darkened, carrying a burnt, acrid smell, a sign of chemical corrosion, not just normal wear. The environmental risk is just as severe. Short-chain chlorinated paraffins are now classified as substances of very high concern in the European Union and have been banned from many industries due to their persistence and toxicity. Even long-chain versions are under review as regulators weigh the cost to ecosystems. The consequences of using these additives are permanent, with both engine and environmental harm that cannot be reversed. Solid particle friction modifiers like PTFE, graphite, and molybdenum disulfide are often sold as miracle lubricants, but their real effect is anything but miraculous. NASA's Lewis Research Center and the University of Utah both tested PTFE-based additives and found the same pattern. The solid particles do not dissolve. Instead, they clump together, forming a sludge that collects in oil filters and in narrow passages. Pressure readings in the Utah test showed a clear drop across the filter, signaling restricted flow. Instead of reducing friction, these solids acted as a dam, blocking oil from reaching critical bearings and cam surfaces. The danger here is mechanical starvation. When oil cannot get through, metal grinds on metal, and engines pay the price. Used oil analysis told the rest of the story. Iron contamination doubled, a sign that wear actually increased after treatment. No lasting benefit was seen in friction or protection. Lab data leaves no doubt. Solid additives clog filters, choke lubrication, and cause wear to double, making them one of the most hazardous shortcuts on the shelf. Copper and metal-based anti-wear additives are often marketed as advanced protection, but the reality for modern engines is far more costly. Zinc dilkyldithiophosphate, ZDDP, was once a hero for flat tappet cams, but today's oils already contain just enough to balance wear protection with emission system health. When aftermarket boosters add extra Z, DDP, or copper compounds, the chemistry turns against you. Excess zinc and phosphorus do not just stay in the crankcase, they burn off and form ash that coats oxygen sensors and catalytic converters. Over time, this ash fouls sensors, confuses engine management, and poisons the converter's precious metal surfaces. The result is check engine lights, failed emissions tests, and repairs that can run into the thousands. In the engine itself, too much ZDDP can create a thick, unstable film that breaks away under stress, a process known as zinc scuffing. Mechanics have torn down engines after a few thousand miles on high zinc additives to find wiped cam lobes, scored bearings, and oil passages packed with gray, powdery residue. The damage does not stop at the engine, it spreads to the exhaust, turning a bottle of promise into a bill for a new catalytic converter. Fake engine oil additives do not just come in flashy bottles with wild claims. They sometimes arrive straight from criminal operations, rebottling used motor oil. These scams collect waste oil drained from engines, run it through basic filters, and then dye it to look fresh before selling it as a so-called performance booster or high-mileage restorer. Laboratory analysis of seized samples shows high levels of fuel dilution, oxidized base stocks, and a cocktail of wear metals, iron, copper, and lead, left over from the engines the oil came out of. Instead of protecting your engine, these bottles dump abrasive grit and corrosive byproducts right back into the crankcase. Customs and consumer protection agencies around the world have intercepted shipments of these rebottled additives, often finding entire shipping containers loaded with counterfeit labels and shared bottling lines. In Southeast Asia, the Middle East, and Eastern Europe, authorities have seized thousands of liters in coordinated stings, but the trade continues online, especially through third-party sellers. With no ingredient list, no quality control, and no accountability, every bottle is a gamble. Unknown contaminants can accelerate wear, clog filters, and destroy an engine in unpredictable ways, sometimes after just a single oil change. The threat here is not just bad chemistry, it is outright fraud, and it is global. No single bottle poses a greater threat to your engine than the so-called miracle additive with a mystery label. These products skip the ingredient list entirely and trade on wild claims like restore compression, repair head gaskets, or double engine life, yet they never reveal what is actually inside. Some are just relabeled solvents or cheap base oil. Others are worse, lightly filtered waste oil, industrial chemicals, or banned substances with no testing data, no approvals, and no accountability. When poured into a modern engine, there is no way to predict how these unknown brews will react with precise oil chemistries. One batch might contain aggressive solvents that strip away protective films, while another could be loaded with abrasive particles or corrosive agents that eat away at bearings and seals. Mechanics have seen engines come in with catastrophic failures, sludged oil passages, seized bearings, or destroyed emission systems after a single treatment with a mystery additive. Warranty inspectors take note too. Most automakers now include clear language in their manuals. Do not use aftermarket oil additives. Damage caused by such products is not covered. That means a $20 gamble on a miracle cure could void coverage on a $10,000 engine. With no ingredient disclosure, no quality control, and no manufacturer standing behind the product, every bottle is a roll of the dice. All the risks shown so far, clogged filters, corrosion, seal destruction, are possible, but the outcome is unknowable until it is too late. In the world of engine protection, nothing is more dangerous than betting your investment on a complete unknown. Leaky moly Ceratec stands out in a crowded field of aftermarket oil additives by taking a different approach. Instead of relying on large solid particles like PTFE or graphite, Ceratec uses a blend of microceramic compounds, specifically boron nitride combined with an organic molybdenum friction modifier. The manufacturer says these ceramic particles are engineered to chemically bond to metal surfaces inside the engine, forming a low friction layer that helps reduce wear without circulating as free solids. This is a crucial distinction, and while earlier additives risked clogging oil filters and starving engines of lubrication, Ceratec is marketed as filter safe, designed to stay suspended and avoid plugging even high-efficiency filters. Reports from European taxi and commercial fleets suggest that when used as directed, Ceratec can contribute to quieter operation and lower wear metal readings in oil analysis. Some mechanics and enthusiasts have noted smoother running and less engine noise after treatment, though these observations remain anecdotal and uncontrolled. Unlike aggressive seal swellers or chlorinated additives, Ceratec contains no harsh solvents or corrosive agents. Still, it is important to recognize that there are no independent, peer-reviewed studies quantifying real-world wear reduction or definitively proving its particles always pass through every modern oil filter. For drivers seeking a supplemental wear reduction strategy, especially in high mileage or hard use conditions, Ceratec offers a plausible, filter-safe option. The strongest evidence comes from user experience and manufacturer testing, not from large-scale independent trials. Arcoil AR99100 stands out among the few additives with a real following among diesel owners, especially those battling injector stiction. Instead of relying on metallic compounds or solids, AR9100 uses a blend of ester carrier oils and a proprietary boron-based chemistry. The goal is to form a protective film on metal surfaces without producing ash or leaving behind deposits that could threaten emissions equipment. This ashless formulation means it is compatible with diesel particulate filters and other sensitive after-treatment systems found in modern trucks. The product's reputation grew in diesel communities, particularly with Ford Powerstroke 6.0-liter and 7.3-liter engines, where stiction in HEUI injectors causes cold start misfires and rough running. Many fleet managers and independent mechanics report that regular use of AR9100 leads to smoother starts, quieter injectors, and fewer stiction-related misfires. While these reports are mostly anecdotal, oil analysis from some treated engines has shown lower iron and copper wear rates after treatment. Lab bench tests, such as the ASTM 4-ball wear test, have demonstrated a measurable reduction in wear scar diameter when AR9100 is blended into base oil, supporting its anti-wear claims under controlled conditions. Unlike additives that risk filter clogging or catalytic converter poisoning, AR9100's chemistry is designed to avoid these pitfalls. It doesn't contain chlorinated paraffins, zinc, or phosphorus, making it safer for modern emission systems. While there are no large-scale, peer-reviewed studies confirming its long-term benefits, the combination of plausible chemistry and strong user support has made AR9100 a go-to solution for diesel owners facing real stiction issues, offering targeted help where standard oil alone sometimes falls short. Hotshot's secret stiction eliminator targets a problem that plagues many diesel and direct injection gasoline engines: sticky varnish and sludge that build up on injectors and critical oil passages. Sticky deposits can foul injectors and restrict oil flow. Instead of relying on harsh solvents or quick flush chemistry, this additive uses a powerful blend of detergents and ester-based cleaners designed to dissolve deposits gradually over the course of an oil change interval. The process is controlled, and there is no sudden release of sludge that can clog screens or starve bearings. Commercial trucking fleets and bus operators have reported fewer injector misfires and smoother cold starts after running a cleaning cycle with Stiction Eliminator. Data from fleet maintenance logs often show a drop in injector-related trouble codes and less downtime for cleaning or replacement. Real-world experience supports these observations. The chemistry works by breaking down the varnish layer molecule by molecule, restoring proper movement in hydraulic injectors and spool valves without attacking seals or thinning the oil. Unlike aggressive flushes that risk stripping protective films or causing sudden blockages, Stiction Eliminator offers a targeted, measured approach to deposit cleanup. Restoring proper movement while preserving seals is the goal. For diesel owners dealing with rough, idle, cold start misfire or sluggish response, this additive has become a go-to solution, backed by real-world results from vehicles that rack up hundreds of thousands of miles each year. BG-MOA stands apart from the sea of over-the-counter oil additives by taking a professional approach rooted in decades of shop use. Instead of being poured in on a whim, MOA is typically applied as part of a controlled maintenance service at dealerships and independent repair shops. Its formula combines balanced detergents, dispersants, and antioxidants, ingredients designed to supplement oil's ability to handle severe service like extended idling, towing, or high heat driving. The goal is not to mask symptoms or to thicken the oil, but to extend the life of the oil itself, helping it resist breakdown and maintain its protective qualities under stress. Shops that use MOA often back their service with warranty-style guarantees, promising coverage against certain engine failures when oil changes are performed on schedule with BG products. This level of confidence is rare among additive makers and signals a commitment to long-term engine health, not just short-term fixes. Unlike do-it-yourself thickeners or stop leak bottles that risk disrupting oil chemistry, MOA is formulated to work within the boundaries set by oil manufacturers, offering a layer of supplemental protection for engines facing real-world abuse. Its long record of safe use, when applied according to BG's protocol, reflects a philosophy of prevention and control rather than gambling on miracle cures. Lucas. Heavy-duty oil stabilizer has earned a reputation as a last resort tool for engines showing their age. Unlike most additives, it doesn't try to clean, flush, or chemically alter the oil. Instead, it's a high-viscosity supplement, essentially an ultra-thick oil booster designed to raise the overall film strength inside a tired engine. Mechanics often reach for Lucas when a customer's car is burning oil between changes, or when hot idle pressure drops low enough to trigger warning lights. By thickening the oil, Lucas can help reduce consumption and quiet noisy valve trains, buying time for engines that might otherwise be headed for a rebuild. Field reports from shops and drivers sometimes note a measurable bump in hot oil pressure, especially in worn bearings or lifters that have developed extra clearance over the years. But the same thickness that helps at high temperatures can turn into a liability on cold mornings. Too much stabilizer can slow oil flow at startup, risking starvation in tight passages. For modern engines with precise tolerances, or for those still under warranty, most experts warn against using any thickening additive. But for high-mileage engines already past their prime, Lucas heavy-duty oil stabilizer can serve as a pragmatic crutch, helping owners squeeze a few more miles out of a tired motor when a full rebuild isn't in the cards. Used sparingly and with an eye on oil change intervals, it's a tool for specific problems, not a universal fix. Across all 15 additives, one truth stands out. When it comes to engine protection, chemistry is not guesswork. The divide between damage and benefit is razor thin, and one wrong choice can destroy thousands of dollars in machinery. In a market flooded with hype and shortcuts, informed decisions are not just smart, they are essential. The real safeguard is understanding what your engine truly needs, not what a bottle promises. Thanks for watching. Share your thoughts below.